Welcome. This is the Shape Import Export utility for Civil 3D. My name is Christopher Fugit. I'm a licensed civil engineer in the state of California. I'm a former Civil 3D certified professional. I'm not really sure if they expire, but I'm going to call myself former because I haven't taken the test in a while. I also do programming. My company is Civil Reminders, and I have a blog, Civil 3D Reminders. All opinions and views expressed in this presentation are mine and do not represent any other party that I may have an association with, including my employer. So why do we have the Shape Import tool? Why has it been created? Is Civil 3D suitable for processing survey data? Right, we have two methods within Civil 3D to do that. One way is the survey database. I find it hard to use. You have to check out an object. You have to modify it. The data to remove, let's say, crossing break lines or feature lines or survey figures. And then we have no connection between the survey figures and the points that we modified and the survey software that collected the data. We can also use text files, but I find that user-defined properties sometimes magically go away, indicating that they aren't reliable. And they're really hard to use to go and grab that data out of it. You can really see it, but you can't really do anything with it. And there's no connection, once again, between Civil 3D and the survey software. If I make a change, I have to go make that same change within my software processing file. And then we have to ask, is there a better way? Do the surveying software companies do it better, right? And in this discussion, I'm going to focus on Trimble products because that's what the Shape Import tool was developed using, and more specifically, the Trimble Business Center. From the surveyors that I asked about it, they say it's easier to use than Civil 3D. So it's got better survey processing tools, and it maintains the connection better to the survey observations. Since the survey company is running on the data collectors, and we're using the processing software, there's just a better interoperability between the values or the software products. So how do we solve this issue of Civil 3D and Trimble, and how can we make that process better? And so this leads to the Caltrans surveys asset collection method, or CSAC. And Autodesk, Trimble, and Caltrans got together and came up with a workflow, and this has resulted in CSAC. So the CSAC workflow is that we have data collection. So in the field, we're going to use Trimble Access and the Trimble data collectors. And it's going to collect the data, and it's going to have all the attributes that we need within the data collector to collect the data in the method that is required. Then that data is going to be pulled into Trimble Business Center and processed. So we're going to make sure that all our feature lines aren't crossing, all our points are correct, all our data, and if anything that needs to be changed is changed within Trimble Business Center. And then we have a link between the survey data collection and the processing. And then we export it out to Esri shape files, and those shape files can then be imported into Civil 3D using the Shape Import tool. We're using shape files because they don't support curves. Different software packages support curves in different ways. And so to prevent any ambiguity on how those curves should be, we're going to use shape files and tessellate all of the curves to prevent that question. So what the surveyor says that curve should be is going to be what it is because it's going to be tessellated. And the shape file is going to retain that information. Some aspects of the CSAC is alpha coding. So in Civil 3D, sometimes it gets confusing because people want to use point number, and that can just be an integer. But really, they want to use naming convention or the point name feature within Civil 3D, and that allows both numbers and letters. So the CSAC is going to use alpha coding instead of point numbers, and then use the name field within Civil 3D. By using traditional data, we have just like a description, a point number, northing, easting, and some other information. But we're going to turn that on its head and use the data for attribute for points and feature lines to give us more information and more control over the data. So we're going to leverage the coding for the attributes and mine that data to provide ways of grabbing the data and visualizing the data. So we're going to have different surface types or attributes to the points and feature lines to determine what they represent. For instance, we might have ground points, and those ground points would then be applied to a surface. So if it has the ground attribute, we're going to add it to our surface. And so for the user who's creating this existing ground surface, right, they don't have to think very much. We have the ground attribute, so that indicates it was collected in the field, indicating that it'll be added to the surface. And so then we can automatically use that attribute to add it to the surface. We have some attributes because we want to model the bridge deck, the underside and the ground and the top. That way we can check clearances underneath the bridge. And so we can use the attributes to go and collect all of the bridge and create those models that we need to verify we have enough clearance under or below the bridge. And then we might have features like metal beam guardrail, signs, and other features that don't necessarily belong to ground, but we want to collect that data. We can then link photos and documents, right? Because if someone takes a photo out there, or the surveyor takes a photo, we want to have a link between the survey data and the image. So CSAC methodology is going to allow us to have a picture out in the field. It then gets attached as the file name to the point as an attribute, or we may have like a document, such as a easement, and then we're going to have that link. So in Civil 3D, you can click the link, and it's going to open up that document or that photo to easily be found. And we can have multiple coding at the same point. We can have a feature attribute and a ground attribute at the same point or along the same feature line. So maybe I'm collecting the metal beam guardrail as a feature, but it's also going to be a ground point. And then we want to make sure that our symbology is the same in TBC and Civil 3D. So by using the attribute coding to control how our information is displayed, we can then get the same look in TBC and Civil 3D. And the user doesn't have to do a lot of assigning of styles. Everything is done automated for them because someone spent the time setting up the system. So we have the same symbology. So an example of feature code library that we can use within this process is that we can have some feature code categories that kind of split up what we're going to collect in the field into different categories. For instance, if I have a canal, I'd want to use the hydrographic feature code category to help me filter those and put them in one bucket of data. And then I can have another one for traffic control devices that I want to collect within the field. And then under each feature code category, I'm going to have a feature code that I can use. So for some examples, I could have the roadside, and I could have the asphalt edge. And that would be my description. I can have my code of AC, and then what type of object I'm going to use this for, right? So in this case, it's going to be line. For structures, I may want to collect the bridge rail, and that code is going to be BR, and that's going to represent a line. And then I can have points. So maybe I have a drainage inlet center, and then I have my code, and then that's going to represent a point. So as a surveyor is collecting data, they can put it in a feature code category. They can then add a feature code to it. And then as we go through, we'll see that they can add more attributes to it to indicate what it represents. So my existing ground line might also, I can determine if it's in dirt, pavement, vegetation, or grass. And so the shape import process is that I have queries. So as I'm bringing the shape file in, I can query the data to put it on the correct style and layer. I need to set up my styles so they go on the correct styles. And then I'm going to use property sets to bring in that survey data and attach it to the feature line or COGO points. Now, when I talk about this shape import process, I'm primarily going to focus on the Civil 3D objects, but be aware you can also bring it in as AutoCAD points, 2D polylines, and just regular AutoCAD 3D polylines. So maybe if your deliverable is to non-Civil 3D users, you can set up this process to not use any Civil 3D objects and deliver it to them. And if they can view the property sets, they can view that attribute information, but they also have the line work in a format that most other CAD packages can view and interrogate. So let's talk a little bit about queries. So queries are going to allow us to go grab that code information and bring it within Civil 3D. So for instance, there may be a property bringing in my data for accuracy, and then I can grab a value for it or set what value it should be in order for it to be applied within this data. So for instance, here I have the control monument for supplemental horizontal. So if the shapefile name is control point.shape, it's going to apply and look at this query to see if it should be applied this information that is contained within this COGO point. So here I have my supplemental control, and then I have type, and if it's horizontal, it's going to be applied this information. And down below, I have a text representation of that query. This query language should mirror what's shown in Map 3D, and so it should use the same notation. So if you wanted to just type in the values, you could do it down here. Or if you're more comfortable with the UI, you can type it in here. So you're allowed either method to create this data. So once we get it into the drawing, we also want to query the data within there, within the drawing. And so we have the option to have queries within the drawing, within the Shape Data Manager. So I can have pre-built queries within my template. So when I open it up, it's already going to be there. So in this case, I have some bridge deck surface lines, and I can tell because there's a little plus sign here indicating that there's data within it. And it's going to show me feature lines or points that have that attribute. So in this case, there's a property set that's indicating is it in the surface. And in this case, I have feature lines, and it's no. So in this case, if I'm building a surface from this data and I want to check to see that all of the data has been included, I could look at this query and say, oh, I have feature lines that aren't included in the surface. I need to go and grab that. If I need to go and select those objects, I can just right-click on the feature lines query and select all of those in the drawing and then add them to my surface as a break line. So we're using the survey data we're using the queries to go and see what data information is within the drawing. And then up here, you can also see the import events. So styles controls the topology or how the information is displayed in both Civil 3D and Trimble Business Center. And so as the information is brought in, it's going to use those queries. So in this case, if the file name starts with barrier_bottom and it meets the query of bridge deck, it's going to put it on the correct layer. It's going to assign the correct style, and it's going to give the feature line name format the correct one. In this case, BBAR stands for bottom of barrier, and we can also put it in a site. In some instances, we might have duplicate queries that a feature line may be applied to, and in those cases, we have a priority, and a priority 1 is the one that's going to be used. If it's priority 2, it's not going to be applied that style. So if there's a conflict, you're allowed to give it a priority to determine which one should be in charge. And you can make the queries as complicated as you want. So down here, it gets a little more attribute. It's looking for more attribute information based on it. And then down below, we can see that it comes in and stylizes the feature lines as needed. So as it's bringing in the data, it's going to add it as property sets. And those property sets are based on what information is being brought in. So if I click on the property sets dialog box or button here, it's going to open up the shape property sets dialog box where I can see what type of property sets it's going to import in. So here it's going to bring in the feature. It's going to bring in the shapefile information. Here I'm going to store what feature code library it's using. And then it's also going to assign the surface status of in surface. And by default, that's going to be a no. And in that way, I can leverage my property set data to then mine how my objects are being used and where that information came from. Now, in order to use this in surface, the user would either add them to the surface and then manually add it as modify the property sets, or you could write a Lisp routine or .NET routine to automate that process, or maybe even Dynamo. To have a button that would go and find all of the property sets that are in surface equals no, grab that information and add it to the surface. We can also view the property set data after we import it into the AutoCAD properties. So here I have quite a bit of data that gets brought in, or possibly brought in. In some cases, the property sets may be empty, and as a surveyor, I may want to add in a file that I collected doing my office work and add information to it. Here I have my category, my DTM type, and then my feature and the material. And so you can add in that information. And then we also have the shapefile information. So we need a connection between it and the shapefile that brought in. So it's going to tell you when this was brought in. I know sometimes I bring in data and then I'm like, when did I bring this in? Or is there newer data available? So the import date allows me to visualize when that data was brought in and then recognize if additional data needs to be brought in. You can give your import events a name. And then you have the shapefile date. So this was when the shapefile was created on the file system in Windows Explorer. So I can see how old that file is and see if there's a newer one available. And then the name of the shapefile, and then the path to that location. And then we also want to be able, like going in the AutoCAD properties is really cumbersome, and really we don't want to have that workflow. We really just want to be able to hover over the line work and show the property set information really quickly. So after you install the shape import tools, it'll be added to the toolbox. And then there's a show property sets option within the enhanced tooltips that turns it on, and then you can see that information just by hovering over the line work. And then we can also see it within the product. And here's just a view of the shapefile path, viewing the entire path. So if you want to know where you brought it in or where that file is, the user can go and find it. So we want to add in those photos and documents. And so a user can either type it in or add that information. They can add in just the file name, or they can do a full path to the file. It's going to look at the file extension to determine if it is an image. And then once the image is found, it's going to add these little icons, these three little circles that indicates that there's a file attached to that line work. Up at top, it's going to tell you, if you have the tooltips on, that if you press the control key and click on the object, it's going to open up those links. If it's a missing link, it's going to give you the opportunity to find it. So in this case, it wasn't able to find my au.png. You're able to change the root path to where that data may be. Maybe you have a workflow where it goes into one folder for your images and photos from survey, and it goes into another folder for your actual design documents. So this allows you to change the root path, and if that au.png file is found within that root path, then it's going to show you the found at location. And so in this case, it'll also open up in multiple links. And so it'll show you where that saved path is, the location where the file is located at, and the file name. And then you can double click on the object and open up that file location or open up the file directly. If there's missing links, as I indicated earlier, you can click on the root path, change it, and then once it finds it, it'll add it to the list. So what does the future look like? So this just describes what the current state is. And in the future, we might have a database instead of shapefiles. And then have a common data repository so we have all of the data in one place. And that database might reside in ArcGIS. And then hopefully Trimble Business Center and Civil 3D will then connect to the database and then pull that data in. Today, you can probably do this workflow with ArcGIS and Trimble Business Center. And hopefully someday with Civil 3D, we'll have that same query power to bring in the data and stylize it as needed. And hopefully that comes to pass. So if you want to observe this and try it on your own machine, you can find some sample data on the Caltrans website, since this was CSAC for Caltrans, whatever. So you can find it in the consultant files. You can find the Caltrans Survey Asset Collection Feature Code Library zip file. It contains a PDF of the instructions, what the feature codes are, and the feature code classifications. If you want a template that's set up, you can find it within the Caltrans Civil 3D 2020 resources, and you can go and grab that data. So that concludes this. I need to come up with another eight minutes of talking. But if you have any questions, now would be the time to ask because we have 30 minutes left.